Hi, in this lesson, we'll work on our roots. Right now, they don't look very nice. They're not very convenient to declare and use. Currently, to declare a single root with parameters, we have to write 3 lines. That's one issue. 2 issues. In apt.sx, we have to, let's say, pass certain route declarations twice. Then there's the problem that we have to pass this s as parameters. This is our page where we take parameters from the URL, pass to this URL. And here, we have to concatenate the string like this when we just want to get abs URL. I've already created a pump.get.road file in our web app in the utils folder, but I won't show it to you now. I'll first show how it will be applied. Applied? Because when you write some kind of wrapper, I remind you again, it's worth thinking first about how you will use it and only then define its contents. The rule is this: it should be easy to use, and let writing be hard, it's no big deal, because you write a wrapper once and use it a huge number of times, and not just in one project, but in all subsequent ones. All right, let's apply it. First, let's apply it to the file roads.ts, and the code was like this, and it will become like this. Okay? Look, everything has become much more neat. I shortened the name of this function from pump.get.road to pgr, and into it I pass the usual road. If it has no parameters, we pass this function and it returns some string. If we have parameters, we pass an object in this format as the first parameter, and then a function which takes the value. Here's our idnic and passes it into the path. That's it. It looks nice here. Okay, let's go fix our app.esx and update everything with the current code. The current code will look as follows, so. Here are our roots. They were like this, but as I said, the problem is only here, and it becomes like this. What's changed? We now use not the call of the function with roots, obtaining a root and passing parameters into it, but we call some definition from the getNewIdRoad function itself. And the entire definition is stored there. We know the definition thanks to the fact that this function is actually quite complex inside. It's become convenient as well. We simply wrote road and definition, and we don't worry about what the input parameters are. If we want to know the inputs, we go here and find out. Good. We fixed it here. Then let's go ahead and change the use, param call on these pages. How does it look now? For example, the view ID page. Now, the parameter call looks like this. It was like this, and it will be like this. Like this. Get new ID road, import it, and just call use param from it. Here the parameters are already of the correct types. Good. On the edit ID page, it's a very similar situation. It was like this, and it became like this. That is, everywhere we only need to import the road itself, and inside it hides everything necessary. All right, okay? No extras here, Okay, done. It's nice here too. And now, let's fix the backend. On the backend, it will be like this. Get new ID road. And our any road can accept an object. Besides parameters, we can also write yes, ABS, ABS, true. And then we get back. Okay, everything works. Okay, 1 second. Yes, something froze. It's fine. And now, instead of just returning /ID, the full URL with HTTPS and the address of our front end will be returned. Everything's working. First, let's check that it's functioning and our front end hasn't broken. All URLs still work. And if we register, let's sign up. Let's check if the email shows the correct path too. For example, at example.com, 1, 2, 3, 4. 1, 2, 3, 4. Sign up. Let's look at the backend logs, okay? And we see that the path turned out to be correct. Yes, our ABS also works. Well, as you might have guessed, if the wrapper is so pleasant to use, it must be quite difficult to write. Let's break down the code of the wrapper itself. Pump get road. Well, let's go from top to bottom. Declare base URL. Ideally, it should be taken from environment variables, but we'll have an issue with this because we use our root in both the backend and front end. And in the front end, our environment variables are actually in import meta-env, while in the backend, our variables are in process-env. And if we try to access import meta-env on the backend, there will be an error. On the front end, there will be an error if we access process-env. And this, in general, is a problem that we will solve in the next lesson. For now, we will just hardcode our front-end URL. We need it to ensure that ABS true works and displays the full value. All right, then we will declare a type, which is pump get road input, what we pass here in the root. Any route can accept, apart from its path parameters, also ABS, true. So we will reserve this ABS. All right, we indicated that the default input parameters are ABS, which can either be omitted or, if specified, must be Boolean. Then we define the pump get road function itself. Later, we export it under the name PGR. PGR is just an abbreviation to make it easier to write here. Okay? As we can see, PGR can accept a function with no input parameters, or it can take just one argument. Here, PGR is this function. Sometimes, PGR has two input parameters. There's a description of the parameters in the URL, and a function that, when called, also passes these parameters. So essentially, there are two ways to call this function, with one argument and with two, and they will work differently. Therefore, we do what is called overloading. Look, we declared this function 3 times: function pump get road, function pub get road, and function pump get road. Actually, the code for this function is declared only once in the last declaration. But, as we see, we said here that it's either route params or get road, and here it can be get road. So, we don't know, and the types are generally any, because this is the final implementation. And in the overloads above, we showed what types actually occur there, indicating 2 possible states. Here, for example, we specify that the function can be called like this. What is actually passed here is get road. It's a function without input parameters that returns a string, and also it's the function itself. But we also said that this function, in addition to itself, has placeholders, use params, and definitions. And thanks to this, here this function, even though it's a function, has some additional parameters. There's dot definition here, or, for example, dot or, for example, dot use, params here. Okay? So once again, I'll note these are its input parameters. This is what we're calling here. These are the input parameters for this function, and this is a description of what it returns. And it returns another function, like getSignOutRoute or getIdeaRoute, which can be used on the page to navigate. This is still just a regular function as well. All right? Good. All of these are input parameters for pump.getRoute itself. What it returns is a function that takes route params, which can be quite basic, simply abs. There are no input parameters in this case. And this case describes this, but not these 2 routes. These 2 routes are described by this case, when we had 2 parameters here. Route params definitions. That is, this is such an object where we have a key followed by a : true. And as a second argument comes getRoute. And here getRoute is already a function that takes route params, but also returns a string. That's all. And we see that pump.getRoute takes these two arguments and returns again a function, as in this case. But here the function is more complex. Here we have route params, which also have base values like egbs, boolean, here, including some object taken through generics. Let's take a look at it. What do we have here in generics? One generic, so let's call it T. It supposedly extends a record where keys are strings and values are Boolean values. How do we now use this generic? We pass it into route params definitions, and it will define their actual type. This means that the generic will be assigned this exact type, where we have key ID and nick and value true. Good. And in getRoute, we return a record where the keys are exactly the same as in T, literally ID and nick, and the value is a string, because there will be some actual values passed in the URL parameters. And that's it. This function returns a string. We also have these three additional properties of the function, excluding the function itself: placeholders, useparams, and definition. Definition is just a string that we pass here. For example, placeholders. These placeholders are actually needed under the hood to declare definition. We don't actually use them in the code, but they are fundamentally there. All right? And useparams is a function that, if there were no parameters, will return an empty object. This is for this declaration. And if we passed parameters, it will return a record with the same keys as in K of T. K of T are these keys. There can be more parameters here. You can add xxxx123. And then here, accordingly, you can also specify xxx and use it further. Only here you need to add true in this case, and it will be here. Okay? That means we can define as many parameters as we want with this. So, well, I roughly showed by types. Need to look at the implementation, and then the types will be clearer. Here, in fact, the only new thing is that functions can have some additional properties. Because in JavaScript, everything is an object. This function is also an object, and it can have some properties, except for being a function. That's one thing, news. And two, you can use overloads and declare different behavior in terms of types for functions depending on how they are called. In this case, with 2 arguments or with 1 argument. Okay? Now let's look at the implementation. Route params definition. Here we need to check, because in any case this function will be called, and here we may have either route params or getRoute. Here can be getRoute, and it will be there if this was called. If this was called, then it will be undefined, and the route params definition begins if the first argument type is a function. This is in this case. So, the route params definition is an empty object, because if we passed a function first, then we assume there are no input parameters. But if it is still not a function, then the first argument is the route params definition. This is in this case good, defined. Then the getRoute function itself. Again, if the first argument is a function, then it is the getRoute. And if the first argument is not a function, as in this case, it means the function is the second argument. All right? And we say maybe getRoute, second argument. Okay? Now the placeholder. We had these placeholders earlier in our routes file. Here, roughly the same logic remains. We take the keys from the route params definition. So it's possibly this one, or it could be an empty object if this one was invoked. Okay? We take its keys and iterate over them to create an object where our keys have the same names, but their content is no longer Boolean, but this colon and key name. We need them precisely to generate these definitions. That's it. We've set up the placeholder. Now, let's define the definition itself, Our definition is like calling the getRoute function, that is, this one here, and passing the placeholder as the ID parameter with a colon. So, when we call this getRoute with a placeholder, currently in the placeholder, we likely have the following. Now I'll minimize it a bit. The placeholders will have this ID object. Well, yes, if this is our root, for example, here we'll have an ID colon string which is written like this, ID. If we pass these placeholders here, the getRoute function will be invoked. This one. The ID here will be that very string with a colon, and, accordingly, here we'll end up with such a string as a result. Just the line that needs to be written right here. Okay, let's put it back. Remove this. All right, we've defined the definition. Now the pump getRoute function itself is pumped, already pumped. Yes, that's what this function returns. That is, the very function that is used on the page. For example, here edit idea page, we have a link here, yes, to get view idea route. So this is what our function itself returns. The pump getRoute function, another function, we need to set it here as well. This is the pump getRoute. It can accept route params because why can't it? Because here, for example, there are no route params, but here there are route params. Therefore, in practice, it is undefined, but it's purely a rect type, and we don't need them that much. The actual types of this function were defined here. Therefore, inside here, we cannot worry and write any when we want, because it will remain purely inside this function. We specified the actual types here. Good. So, let's see how this function works. It finds the route itself through the getRoute function, with the route params passed into this function. If a point ABS was also specified in route params, then we will return the base URL plus the route itself. If ABS was not specified, we simply return the route itself. Here one could write like this, and it would be the same, but I think it's not very readable. And like this, it is readable, right? But in this situation, yes. Literally, if this, then that. If that, then this. Often we actually return to write a lot of code further on that won't interfere. But when it's short, it's better to write like this. Fine. But it's just a matter of stylistic preference, that's all. That is, we generated all necessary values and now we need to apply them. Here's our function. We take it and insert placeholders into its .placeholders. Insert the definition into .definition. And in useParams, we insert the regular useReactParams. We took useParams from here and renamed it to use ReactRouterParams to avoid a name conflict. And then we pass it as any. This is just to pass it here easily, so that we can use it like this here. In fact, it's like calling the regular useParams from React Router DOM in JavaScript. But in this case, we get some non-obvious types in idea nick. Since we declared all types in our function, we have the correct types here. So the function works exactly the same, but the types here are different because we designated them here. All right, and here is the function itself. Also, somewhere, sometime, we might need the route params type, which we can call separately. Okay, well, maybe it would be useful, but for now it seems redundant. Let's just remove it. If needed, we'll create it then. For now, this solution fully satisfies us. All right, so, or should we keep it? Okay, I'll leave it, because it might be useful to you in the future. That is, you might need it on some page, for example, in the layout. Yes, in the layout, you use some root parameters from various URLs. If only one URL can always be displayed on the page, then the layout can be displayed by URLs of different pages. If anything, you can use it in this way. For example, you may need this type. You define type XXX, equals root params that you export from there. And here you pass type of and the name of the root. And here you know that getNewIdRoot has no input parameters. If you pass getEditIdRoot here, you'll get an idea of a string ID. In our project, this is not needed right now. In yours, it's very likely to be useful. That's why I'll leave this type here. Fine. Well, it works quite primitively. So, we're specifying a generic again. We say it extends a certain object that has a key placeholders. In fact, all our routed props have placeholders. So, we defined it that way. And it just returns the type of these placeholders. That's the whole type. Good. As usual, the wrapper is a bit complicated, but from the TypeScript perspective, we practiced a bit. I hope you can understand this code, but you can definitely use it. Use it either way. As we established, it's challenging to write, but it greatly enhances JavaScript and TypeScript skills. All right, thank you all. Let's move on.